Okay, everybody can see where they're sitting. Are you sure you can see? Because my back, yeah, I'm going to move over one. All right, this first part, are we having trouble with the graphing points here? Let's just do a few of those. -2, 120. If this is 90, this is 30, this is the 120 right here. Instead of going to here in quad 2, it's going to be in what quadrant? 4. Very. So it'll be down here. Okay, thank you. All right, come on in, buddy. You can sit anywhere, buddy. All right. 3 comma pi over 4. 3 comma pi over 4. Pi over 4 is here. I'm going to go out to ring 3. Are we good on those? Yeah. Okay. Let's talk about graphing and talk about how we got to be able to identify it, okay? All right, number 7 here. Notice the A and B value. They are the what? The same. So what type is that? Cardioid. Very good. So we're going to graph it by a table. Now we are going to do all 4 of these. All right. This is an old study guide. I don't use this one anymore. I just found this one. Oh, let's see here. 0, pi over 2, pi, 3 pi over 2, 2 pi. Sine of 0 is what, guys? 0 times 4 is 0. 0 plus 4 is 4. Sine of pi over 2 is 1. 1 times 4 is 4 plus 4 is 8. Very good. And y'all said it's a cardioid. Yes, that's great. But what is that going to look like? That's going to be a dimple at the what? Pole. That's what you got to be thinking in your mind, okay? All right. Sine of pi is what? 0. 0 times 4 is 0 plus 4 is 4. Sine of 3 pi over 2 is -1. -1 times 4 is -4 plus 4 is 0. And then, of course, this will be 4. All right. Put a dot up there somewhere. And I know I got to have a dimple there, so that's why I put the dimple right there. All right. Looking at number 8 there, guys. We got 5 cosine 2 theta. This 2 theta right there, what's that let you know that's going to be? Oh, rows. Very good. So no rows. It's not how many totals? 4. Very good. How many equations will you have? 2. Very good. Now this is where we're going to be careful here. So I'm going to work it up here. All right, so I'm going to set cosine, because are we going to worry about that 5 right now? No. All right, so I'm going to do cosine 2 theta equals 1, and cosine 2 theta equals -1. Do not divide by that 2 right now. You're not ready to do that. All right, yeah. Now, you got to think, okay, what cosine value gives me a value of 1? 0. So now I'm going to put 2 theta, 0, plus 2 pi n. Cosine gives you a -1 is pi plus 2 pi n.
Do you just do the plus 2 pi because it's just like
that's just a rule, and yes, and the way I remember the period of a sine and cosine graph is 2 pi. That's how I remember. Now I'm going to divide everything by what right here? 2. Now that's where I'm ready to do that. So theta equals 0 plus pi n. All right. There's 4 pedals, so how many numbers will I plug into this equation? In this equation, just this one right here. 2. What 2 numbers will that be? 0 and 1. So pi times 0 is? 0 plus 0 is? Now pi times 1 is? Pi plus 0 is? Now, I'm over here, plug 0 in. Pi times 0 is 0. Plus pi over 2 is pi over 2. Plug 1 in, that's going to be 3 pi over 2. So there's my 4 pedals. I'm going to go out to what ring? Of course it's not in. Come on in, hon. 1, 2, 3. Oop. We're kind of leaning over here on this one. Sorry about that.
Are you good?
Yes. All right. Let's look at number 9. Let's look at 9. That involves a minus, so we know it's a Lamson family. We have to think about what type this is. The absolute value of A is less than the absolute value of B. So is there going to be a swirl or a dimple?
A swirl.
A swirl. Very good. A swirl. Inner loop. Loop less. Whichever way you want to think about it. All right, so here we go. Alright, what is cosine of 0? 1. 1 times negative 3 is? Negative 3 and 1 is? Negative 2. Cosine of pi over 2 is 0, so that goes away, leaves me a 1. Cosine of pi, negative 1 times 3 is positive 3, plus 1 is 4. Cosine of 3 pi over 2 is 0, so that goes away, leaves a 1. And this is negative 2. So instead of going this way, I'm going to be going this way. I meant to do my little loop right there. Which one? This is it's negative 2, 1, 4, 1, and negative 2. Why don't y'all try number 10 on your own, see if you set it up correctly. First of all, what type is number 10? That's going to be a what?
Rose.
Oh, rose. Very good. How many petals?
4.
4. So how many equations?
2.
Very good. Set that one up. Yes. There's a reason I don't use this study guide. It's not pretty.
I just like drawn circles and then put the circles.
Yeah, it's not a pretty study guide. Mm-hmm.
Once I get set up to like 1 and -1, I'm confusing.
That's what I thought you're having trouble. What you need to do now is say, okay, in order to do that, say, what sine value gives me a sine value of 1?
That's what I'm trying to figure out. That's myself. It's those.
Okay, so
It's like
let's-
a personal problem.
Okay, so sine value, unit circle, think back. Sine value, that's the y value 1. Where's y equal 1 on your unit circle? Right there. So you put 2 theta equals pi over 2.
2 theta? Okay. I was,
You see what I'm saying?
I was trying to find like a 0 or 1.
No. You're trying to find the trig value.
I knew it was there, I just didn't know like.
Uh-huh.
Yes, but
Way.
It's right there.
it's never.
Probably ask for it. Yeah,
Not always. Not always.
Yes.
All right. So let's look here. We got sine 2 theta equals 1. Sine 2 theta equals -1. What sine value gives you? What value gives you sine of 1? That's pi over 2. Over here be 3 pi over 2. We're gonna run out of room. All right. Now I'm gonna divide it by 2. So when I say pi over 2 divided by 2, this will be pi over what? 4. Plus these 2's cancel out, plus pi n. Okay. So if I plug, okay, I got 4 pedals, so I need to plug 2 in this equation, 2 in the other. What's 0 times pi? 0 plus pi over 4 is pi over 4. And then plug 1 in, that's going to give me 5 pi over 4. Alright, the next equation, if I divide this by 2, that will give me theta equals 3 pi over 4 plus pi n. So 3 pi over 4 and 7 pi over 4 will be my 4. And that's your answer. Alright, I'm just going to pick like 2 out of each of this section because I want to get to what we've been working on yesterday and today. This is the easy part of the test, this sheet. Like the stuff that we've been doing yesterday and today is not on this study guide, okay? Because this was what I used for pre-AP pre-cal. Alright, so number 11. Let's read the direction. It says, convert the polar to rectangular. So if you're going to rectangular, you need to know 2 things. What are they? X and? So here we go. X equals R cosine theta. Cosine of 270 is 0, so X equals 0. Now Y is negative, that's supposed to be a negative, -2. Sine of 270. Well, sine of 270 is what? What's sine of 270? -1. -1 times -2 is 2. So 0, 2. Alright. Are we good on those, or do I need to do another one like that? Which one? 13, okay. X equals -2 cosine 4 pi over 3. Now, 4 pi over 3, that's in quad what? 3. What's the cosine there? -1/2. So that gives me a positive 1. Y equals -2 sine 4 pi over 3. Sine of 4 pi over 3. -√3 over 2. What happens to these 2's are here? A negative times a negative is a. So I have 1 comma √3. Alright, the next section says convert the rectangular coordinates to polar. These are rectangular. For polar, I need to know what? R and a theta. R and a theta. Alright, so find my R. I'm going to go R equals square root of 1 squared plus square root of 3 squared. That gives me square root of 4, which is 2. Because that would be 3 plus 1. Tangent of theta equals root 3 over 1. Which family gives you a tangent of just root 3? Pi over 3. Very good. Now, pi over 3. Let's look back at our original. What quadrant would that be graphed in? Everybody, what would that be graphed in? 1. So what pi over 3 family member is in quad 1? So your answer is 2, comma, pi over 3. Yes, y divided by x. Yeah. Number 16. Find my r. Negative 1 squared plus 1 squared. R equals square root of 2. Tangent of theta is 1 divided by negative 1, which is negative 1. Which family gives you a tangent value of negative 1? Pi over 4. Now let's see what quadrant that was in. That's in quad 2. So that's going to be 3 pi over 4. So root 2, 3 pi over 4. Do we feel all right with those? Now we're going to convert the equations, and then we're going to go to de Moivre's theorem. This is right.
Was it 15 pi over 3?
Yes, buddy, it's pi over 3. All right, number 18 says write each polar in rectangle. It means you want your r and your theta to go away. Now, right here, do we need to multiply both sides by r or square both sides? What do you think? Because you need an r right here, don't you? Because if you have r sine theta, you can replace that with what? Not that part. You could put y there, couldn't you? So I multiply both sides. That's r squared equals 3 r sine theta. Multiply both sides by r. Now I can replace r squared what? X squared plus, and then r sine theta could be what? 3y. There's your answer. Alright, number 19. Do we need to multiply both sides by r or just square both sides? Square both sides. Very good. So r squared equals 16. X squared plus y squared equals 16.
You wouldn't simplify down to be x plus y equals 4?
No. It's not difference of squares. Alright, number 20. When we have theta, what do we take both sides of? Tangent. And remember, that's y over x. The tangent of 5 pi over 6 will be a negative root 3 over 3. Now, this is an interesting one. If you got it to that part, I'll probably just give you credit on that one. So, couldn't you cross multiply? But like I said, you get it there, I'm good. Now, if it was something easy over there, like 1 or root 3, you should multiply the x across. Are you good on that? Alright, let's look at number 23. It says, write each rectangular equation in polar form. What am I going to replace x with? R. And then divide both sides by what? Negative 2 secant theta. How about x squared plus y squared? What's that equal to? Then I'm going to take the square root of both sides. R equals, when you take the square root, plus or minus 8. And then on number 25, what do I replace y with? And divide both sides by sine. R equals 4 cosecant theta. Y'all feel good on that part of the chapter? Now, I'm giving y'all a study guide tomorrow in class, but do any of y'all want the study guide ahead of time? Now, this study guide only covers this. This De Moivre's theorem and stuff, this is not on the study guide, but this is the other stuff. Just remind me tomorrow when I pass these out, you don't need one. It's on the test, it's just not on the study guide. So if you want to practice it, and let me check something tomorrow, you can. All right. Here we go. Okay, let's get our homework out, and we're just going to work those problems together. Y'all good with that?
Yes. I wasn't going to advertise that because I want to see it show up.
Aren't they good?
Those things are so good. Mr. Esther.
Yes.
I get to go to Texas Roadhouse tonight.
Do
It's
you?
like my second time ever.
Outback is my favorite. Outback is my favorite.
I lost a bet to my stepdad.
Oh.
He's trying to teach me not to bet.
Oh.
I've lost two steak dinner bets. Pay for our dinner. I would have won. Dinner, sorry. This right here? Yeah, you do it. Yeah, you do it.
Oh, isn't that the one like?
So your punishment is you have to
Is he gonna get
No, he's not. All right, we've lost the bonus point page. Hold on. Oh, here it is. Never mind, I got it. Okay, we're good. All right, what's the first problem? Somebody read to me 54. Oh, now before we do that, remember also that you're going to have to graph the complex numbers in the coordinate plane. You all good on that? That's on your test. You're going to be able to determine the modulus of a complex number. If I give you that. I'm going to tell you 2 plus 5i. You got to tell me the modulus. Are we good on that? These two, they're not on your study guide, but it's on your test. Writing complex numbers in polar form, that's on your test. But we're going to practice that while we're just about to do that. Okay?
Is the study guide worth points too?
No. I'll push it. And also, you remember those multiplication division problems where you had to multiply the outside and then add the inside? That's on your test as well. All right, number 54. What is 54's question? Oh, that is. I forgot I gave. Let me see this. Use your book. Well, we'll practice that right now. I forgot I gave you something. Yes, buddy.
What is it? Z1, Z2? Oh yeah, Z1, Z2 where you multiply.
Oh, okay.
Yeah. Oh yeah, there was questions I could not figure out.
All right, 54. We want to. Okay, we got Z1 is square root of 2 cosine 75 plus I sine 75. Z2 is 3 root 2 just making sure I did the right problem. Cosine 60 plus I sine of 60. Okay, so we want to do Z1 times Z2. When I do that, I'm going to multiply these two numbers. What is square root of 2 times square root of 2? 2. 2 times 3 is? Very good. Now, inside you're going to add what? 75 in? So your cosine of 135 plus I sine of 135. Okay, to answer your question, I hope, in the direction it says express your answer in polar form, That is polar form, so you wouldn't simplify it here, okay? Let's make sure that's how they... On these, you're just demonstrating... On this, it's just you're just demonstrating if you know the rules here. Does that make sense? You would not find cosine of 135 and sine 135 because you're just showing me that you can multiply the two. My teacher's edition it has. Yeah, you're fine. My teacher's edition has. Oh, but this is a student edition. You're right. Let me go to my teacher's edition. Not this one.
So you just added the...
Mm-hmm.
I filled this up like 20 minutes ago. It was there. I hit you with the empty bottle.
Yep. All right. Okay, guys. Next one.
I didn't say it was a bad thing.
I'm going to do Z1 divided by Z2. Okay? So square root of 2 divided by 3 square root of 2. And then what do you do with these two in here? If it's divided, you're going to do what?
Multiply.
Nope.
Or multiply the bottom.
Hold on, bro. Hold on. On multiplication, you multiply these two to get that number and did what? You added these, didn't you?
Yeah. Subtract.
Yes, you subtract 75 minus 60, so they give you cosine of 15. What happens to square root of 2's? And that's your answer. 1/3 times cosine 15 plus I sine of 15. Z1 on 56 is 4/5. Oh, 55. Okay. 55. Z1 equals 4 cosine 200 plus I sine 200. Z2 is 25 cosine 150 plus I sine of 150. So if I'm doing Z1 times Z2, what will I do with the 4 and 25? Multiply. What's 4 times 25? 100. What would you do with the insides? Add them. So it's be cosine of 350 plus I sine of 350. All right, now I'm going to divide 4 over 25. And what I'm going to do with the inside now? Subtract. So it'll be cosine 50 plus I sine of 50, and that's your answer. Yes.
It's given to us in the 5/4. Can we convert it to the degree and then add them, or do you want us to have the answer in the?
I won't be able to do
So the convert is.
All right. Now let's go on to Moirier's theorem, number 67. We have negative root 2 minus root 2 I to the 5th. I want to expand this complex number using de Moirier's theorem. Well, what's the first thing I need to do is put it in what form? Polar form. It's going to be in polar form. Okay, so I'm going to find the modulus. And when I square that, what would that give me? 2 plus 2, which is 4. What's square root of 4? 2. Yep. Now, go back to that complex number. If I was to graph that in the complex plane, what quadrant would that be in? 3. They're both negative, so it's in quad 3. Now I'm going to do tangent of theta equals this divided by this. Well, negative divided by negative is positive, so it'll be positive 1. What family gives you a tangent value of 1? Pi over 4, that is correct. Now let's think, pi over 4. Which family member of pi over 4 is in quad 3? Pi over 4, very good. Okay, are y'all good at that point? Do we understand up to that point? Okay, now we're going to apply the de Moivre's theorem. So it's asking to expand to what exponent? Fifth. I'm going through this real slow because I want to make sure we all understand this. So I'm going to raise this. What will I raise this 2 to, Jace?
2 to the 5th.
Very good. Just like that exponent there, 2 to the 5th. All right.
And then the cosine
What do we do next?
multiplied by
Very good. I'm going to multiply both of these by what? Y'all remember that? 5 pi over 4 times 5 will be what? Now I want you to take a moment. Well, we know 2 to the 5th is what? 32. I want you to figure out what 25 pi over 4 is at. Take a moment. Where would 25 pi over 4 be in what quadrant? 1. Very good. Quadrant 1. So what's the cosine of that that's in quadrant 1? Root 2 over. And this would be what? Now, I'm going to distribute that 32. Distribute that 32. If I said this times this, what would happen at 2 and 32? Cancel. What would that be? 16 root 2. Do we understand why it's 16 root 2? Alright, if I distribute that, I'm going to get the same thing. So that is my value for that complex number. I want y'all to try 68 on your own. Try 68.
This is no more than this.
I got 2 more cookies left. You want one? You want one, don't you? Come on. No, I'm good. You're welcome.
Are you having a technical?
Don't say that.
Patrick, I can't focus.
hope you know that when I'm taking my test, I always have your voice in my head saying, what can we do?
Whatever it takes. Whatever it takes.
Yeah.
And if Jace has to do his hand motions tomorrow during test, straight up do it.
Yeah, I saw him do that. I was like, you know, he just goes.
Whatever it takes.
That's actually a really good idea. But it was so funny because I just looked over here.
Alright, let's find the modulus here. What would be the modulus? What did y'all get? We're good on that. Okay. Now, if I was to graph that, what quadrant would that be in? 1. So that's important to know. Tangent of theta equals 1 divided by 1, which is 1. What family? Pi over 4. Very good. So I got root 2 cosine of pi over 4 plus I sine of pi over 4.
Why is the R in front of the sign at first and then in there?
What now?
Why is the R in front of the sign and first? Okay.
It doesn't matter what you. I just always put that first.
Remember, it says that city.
All right, now, what power am I trying to find, guys? 7. So I got to raise that root 2 to 7. Let's review what we talked a little bit about that today. Okay, I'm going to raise root 2 to 7. How can I rewrite 2 as 2 to the what? 1/2. If I raise that to the 7th, what's 1/2 times 7? 7/2. You can just leave it like that.
Did you count off when we did 11 point something?
Yes, I would. Now, let's try this though, because that just bothers me. I want y'all to find out what 2 to the 7th power is.
What, 2 to the 7th power?
Yes.
Or root 2 to the 7th power?
2 to the 7th power. 128. What is it? 128?
Yeah.
I might have to do a decimal on this. Ooh.
No.
Alright, let's just see what happens. Alright. Yes, because I just don't like the way that looks. Okay, let's write it like this. 2 to the 7 is 128, isn't it? That'd be square root of 128. Isn't that equal to that? Because I raised 2 to the 7th power and then took the square root. Now let's break 128 down. I would not give you one like this on the test. 128 is 64 and 2. Keep breaking that down. That's going to be 8 square root of 2. Yep. So I rewrote square root of 2 is 2 to the 1/2. 1/2 times 7 is 7/2. I'm going to say, okay, I got to do something with this. Well, remember, that's why we did workshop, so you could tell me what 2 to the 7/2 was. Raise 2 to the 7 and then the square root of 128 and then break that down to 8 square root of 2. Is everybody good with that? Now, bring this stuff down. Cosine. Okay, now we got to say 7 times what? Which would be 7 pi over 4 plus I sine 7 pi over 4. Now 7 pi over 4. 4 goes in 7 one time with 3/4 left over. So what quadrant is that in? That should be easy. We all should know that's in quad 4. We good on that? Okay, now in quad 4, your cosine is positive. It's root 2 over 2. Your sine would be negative. I don't know why I wrote the I first there. But now, I'm going to multiply this out. We've got to distribute this. Now, let's think how this is going to work here. If I multiply this, what's square root of 2 times square root of 2? 2 times 8 is, divided by 2 is 8. Square root of 2 times square root of 2 is 2. 2 times 8 is 16. Divided by 2 is 8. Square root of 2 times a negative square root of 2 would just give me a negative 2. Negative 2 times 8 is, divided by 2 is, look how pretty that came out. So De Moivre's theorem, you put it in polar form first, raise that outside to that power, and then multiply your inside by that power.
more form when you can evaluate it. Yes.
Oh, better on that?
Better, but
That's why I'm letting you start at zero period.
tomorrow.
You come in zero period Friday and start it.
Well, tomorrow is my Friday.
Huh? Then you better get 35 problems done.
Tomorrow is my Friday.
Wait, what about if I can get it tomorrow?
I might let you all start on the first page tomorrow. The last 10 minutes of class, so you have time to finish it.
What about in zero period?
I might. Huh? Let me just think on that one. Huh? Don't push it.
Start more in zero period.
I can't start in zero. I'll go to Spanish tomorrow morning.
Because you can you can look on the rest of the pages test and go home and study what you need to study. Oh, I know y'all. That's why. All right, let's look at number 77. Now we found the power. Now we need to find the roots. But this is good on 77. What does it say? This what? So we only got to get how many answers? 2. So that means I'm plugging 0 and 1. But once again, I need to put this in what form first? Polar. So let's find the modulus. All right, 4 squared is 16. 16 times 3 is 48. Plus 16 is 64. So square root of 64 is 8. Yes, thank you, Holly.
Stop it.
All right. Tangent of theta equals 4 divided by 4 root 3. What happens to these 4s? Left with 1 over root 3. Now, if I was to graph that, it being quad what? 1. I'm going to rationalize this. What family will give you a tangent of root 3 over 3? Pi over 6. And in quad 1, it will be pi over 6. You're finding the roots. This first part is very similar to de Maurier's theorem. We're going to raise that modulus to something. Will we raise that 8 to a 2 or 1/2? 1/2 because you're taking roots here, okay? So 8 to the 1/2. Now, I'm going to write what here? Cosine of pi over 6 plus what? 2 pi n divided by, what did I put on the bottom?
2.
Yep. Now that's something right here. I want to call your attention to 8 to the 1/2. 8 to the 1/2. I know we can't take the square root of 8, but let's at least write it in radical form because that just bothers me like that. So let's write square root of 8, but can we break 8 down? 2 root 2. Okay, that's what you need. That's the format you need to be able to work with it. Now, let's plug in 0. Here we go. 2 pi times 0 is 0. 0 plus pi over 6 is? Now, I got pi over 6 divided by 2. That's going to be pi over what? 12. Have we ever worked with pi over 12? So are you going to have to be able to break it down anymore? No. So that's your first answer. Box it in. That's your first answer. Yes. or what root you looking for. I'm looking for the square roots, that's why I put 2 on bottom of those. If I was looking for cube roots, I'll put a 3. If I was looking at fourth roots, I would put a 4. Alright, now I'm going to plug 1 in. 2 pi times 1 is 2 pi plus pi over 6. What is 2 plus 1 over 6? Put it in your calculator. I want y'all to practice putting your calculator too right now, because you're not going to be able to ask me on Friday. 13 pi over 6. Put it in your calculator. I want to make sure you get it. 2 plus 1 6. If I plug your 1 in, 2 plus 1 6. Do you know how to put that in your calculator? Okay, now I got 13 pi over 6. Now I divide that by 2. What is that going to be? There's your next answer, and those are your answers. I did look at your test, but one of your tests is only a cube root. It's not a 5th or 6th root. Mm-hmm. I haven't figured that out yet. It won't be worth 10 points.
However much that
Problem.
is, that's how much bonus you should.
Okay, it turns out my sister has to
Let's say there's 3 answers, 2 points, 6 points. That's all we're up for 6 points.
Alright, so let's get 6 first. Yes. That's fine with you? That's fine with you?
Well, first of all, it's not a negotiation. I'm just taking your suggestions, okay? No. Alright. It is. Let's look at 79, the fourth roots of negative 81.
My mom just texted me and she's like, Emma has to be at the trail studio in like 20 minutes. Are you going to actually go get her?
Oh, that's alright.
I got it.
Thank you for coming. See you tomorrow. Okay, negative 81i. Negative 81i. I need to put that by her in polar form first. Okay? Bless you. Z equals Z0 squared plus negative 81 squared will give me an 81. Now, if I was to graph negative 81i, negative 81i, would I go, where would that be at? Where's negative 81i? Straight down. It's like I'm graphing 0, negative 81. You see that? The real part is 0. You always graph the real part first, and then the imaginary. So it's going to be straight down at 3 pi over 2. So that is what you put right here. Cosine 3 pi over 2 plus I sine of 3 pi over 2. We're finding the fourth roots of negative 81i. Yes.
So this is
Yes, it is. This is number 79.
Oh, 79.
All right. Now, does everyone understand how I got this right here?
Yeah. Gotcha.
Okay. Now, I'm looking for the fourth root. So I'm going to do 81 to the what? 1/4 cosine 3 pi over 2 plus 2 pi n plus I sine 3 pi over 2 plus 2 pi n. And all that's going to be divided by what number? 4. And you set the problem up. Now, 81 to the 1/4. What is 81 to the 1/4? 3. Now, if I couldn't do that, I would break my radical down. Can't leave in that form, but this is 3. So this comes down. Now we want 4 roots. That means I'm plugging how many numbers? What 4 numbers would that be? 0, 1, 2, and 3. Very good. Alright. I plug 0 in. 2 pi times 0 is 0. So I got 3 pi over 2. What's 3 pi over 2 divided by 4? 3 pi over 8. We ever work with pi over 8, so are you going to have to break that down any further?
So we usually won't have to break it down anymore?
Yeah. Alright, so we got, so the first one will be 3 cosine of 3 pi over 8 plus I sine of 3 pi over 8. That's my first root, so that's one answer. Next, I'm going to plug 1 in. 1 times 2 pi is 2 pi. 2 pi plus 3 pi over 2. So I'm going to say 2 plus 3 halves, which would be 7 halves. Very good. Now 7 halves divided by 4 would be 7 pi over 8. Very good.
What'd you do to get 7 pi over 8 again?
Type in your calculator right now. 2 plus 3 over 2. Put it back as a fraction.
Okay. What'd you get? 7 pi over 2.
Now divide it by 4.
Alright.
See how I got that?
Yes.
Alright, next, when I done plug 0 and 1 in, I'm going to plug 2 in. 2 pi times 2 is? 2 pi times 2 is? 4 pi. 4 pi plus 3 pi over 2. 11 pi over 2. And then divide that by 4, that's going to be 8. Yep. Are there any questions so far? Alright. The next one, I'll plug in 0, 1, 2, 3. 2 pi times 3 is 6 pi. 6 pi and 3 pi over 2 will be 15 pi over 2, okay? And then 15 pi over 2 divided by 4 is 15 pi over 8. And that's my 4 roots. Do y'all feel better with it?
Yes.
We're going to review all this again tomorrow. Now, since you just did your homework, now use your time when you've done homework to go back and look over this and learn the steps of how to do each of these
I need to
problems.
study that.
I thought you were about to give us one homework.
I was like, oh god.
Or, yeah, you can practice some of that study guide you've got. But remember, this hard stuff like this is not on that study guide, because that was my study guide I used to use when it's just free if you freak out. You're welcome, buddy. You're welcome. We've covered 11 of the 13 chapters in this book. We've got 2 more to go.
We have one more chapter? We need 2 more chapters?
Yeah. Okay. Oh, yeah, I got to load this up too.
Like the